Welcome to today's lesson. We're going to study mathematics, paper 2. This is in preparation to the Kcse 2025 exam. So remember to subscribe, remember to share so that you may invite your friends. We begin with question 1 in section 1. Solve the equation tan squared x plus 2, the root of 3, tan x plus 3 equals to 0 for the range of x between 0 pi radians to 2 pi radians. So for us to solve this one, because we can see the tan of beta has been squared, then we can solve by doing this. We let the tan of x to be another unknown. We can even say t. So that now we introduce our t squared plus 2 square root of 3. Instead of tan, we write now t plus 3 equals to 0. So now we can solve this quadratic equation. T squared plus 2 the root of 3t equals to, we take 3 to the other side, whereby it becomes negative. Yeah, that is what you're supposed to know. T now becomes negative. Once t has become negative, we are now supposed to add a constant. Remember, I'm solving using what we call the completing square method. So I will add a constant to this side. Then I also add the constant, the same constant to the right-hand side. How do we get this constant such that the left-hand side becomes a perfect square? This constant is given by b out of 2 squared. So 2, the root of 3 over 2, then we square. Now this is going to be root 3 squared. When it's supposed to be squared, sorry, which becomes exactly 3. So we are adding 3 to both sides. So the value of t squared plus 2 the root of 3t plus 3 equals to negative 3 plus 3. Therefore, now we can finish up by simplifying the left-hand side. If an expression which is quadratic is usually a perfect square, there is how we are supposed to factorize it, whereby we take square root of the first part, square root of t squared is t, then the sign for which follows, which is a plus, and the square root of the constant part, so root 3 that way, squared. This one equals to, when we combine the right-hand side, we get a 0. You know, now at this point, we can start completing, whereby we will say we can obtain square roots to both sides, whereby on the left-hand side, it will become t plus the root of 3. Now we omit the squared, equals to the square root of 0, which is just 0. So you see now, at this point, we can simply conclude that the value of t is equal to the negative value of root 3. The negative value of root 3. Therefore, we can say what we were calculating as t is the tan of x. So tan x is equivalent to negative the root of 3. And for us now to get x, you know, we need to find, first of all, we need to find a certain acute angle, which is given by tan inverse of the root of 3. Let me check this value. Shift turn the root of 3. This is exactly 60 degrees. So now we will be working with 60 degrees, but in this manner, we ensure that this is an acute angle of 60 degrees in the quadrants where tangents are negative because of the sign just before root 3. So we need an angle of 60 degrees, but in the quadrants where tangents are negative. So look at this. If I draw this, what you call the unit circle, we know in the first quadrant, all trigonometric ratios are positive. In the second one, only the sines. Here, only the cosines. And here, only the tangents. Now, we need 60 degrees in the quadrants where tangents are negative. And that is the second quadrant and the third quadrant. So how do we get an equivalent angle in the second quadrant? 180 minus theta. In the third quadrant, 180 plus theta. Therefore, the options of x, the values of x are 180 minus 60, which is 120, and 180 plus 60, which is 180 plus 60 is 240. Yeah, 240. So these are the only possible angles of x, but now remember they are in degrees Celsius. So we have to convert them into pi radians because of the range given there. And it's good to know that this is between 0 and 360 degrees because 2 pi radians is equivalent to 360 degrees. So look at it this way, whereby we will say 180 degrees is equivalent to pi radian. What about 120 degrees? So 120 multiplied by pi radian divided by 180. So that will be the first angle. 120 over 180. This is giving me 2/3 pi radian. Then we can say the other one will be 240 over 180 pi radian, which will simplify to, when we take 240 divided by 180, this is giving me 1 1/3 or 4/3 pi radian. So the two values of x in pi radians are going to be 2/3 pi radian, and x is also equal to 1 1/3 pi radians. So we have gotten the two values of x in pi radians. Look at number 2, which is a question on logarithms. Solve for m in the equation m, the log of 8 to base 3 plus the log of 4 to base 3 equivalent to 3/4 the log of 16 to base 3. So let's apply a few laws of logarithms. For example, there is the first law which says in case we have the log of a plus the log of b with the same base, then this can be solved by taking the logarithm a multiplied by b. Then again, there is this third law of logarithms, which says that in case we have n, the logarithm of a number a, this can be solved by taking the logarithm of a, then n becomes the power to a. Therefore, applying this third law and the first law of logarithms in this given equation, then from the first term we can say, instead of m log 8 base 3, now we can talk about the logarithm to base 3 of 8 power m. This is now added to the logarithm to base 3 of 4 equivalent to the logarithm to base 3 of 16, and this 16, we raise it to power 3/4. That way. We also apply the same law in the last term. Now, it's good for you to know that at this particular stage, we can apply the first law, whereby we will say we have the log to base 3 of 8 power m multiplied by 4. This is equal to, now applying the laws of logarithm on my right hand side, I'll be taking 16, then I obtain the fourth root, then I raise to power 3. This is a law of indices, which says if we have a number a raised to a fractional index this way, we solve this by taking nth root of a, then everything we raise to power m. Therefore, here we will take fourth root of 16, which is 2. Then 2 will be raised to power 3, which gives us 8 now. So the log to base 3 of 8, that way. So now that we have applied the laws that we could, we can now drop logarithms and we equate the two sides. So 4 multiplied by 8 power m, this is equivalent to 8. To remain with 8 power m, we can divide it through by 4, such that this becomes 2. Now we can use some indices at this particular stage, whereby I'm going to express the composite number, which is 8, into base 2, such that 8 becomes 2 power 3. To know it to be 3, and there is an existing power of m there. This is equals to 2 power 1. Now at this point, because bases are the same, we can equate the indices such that 3 multiplied by m is equivalent to 1, and the value of m is exactly a third. The value of m is exactly a third. So as we continue learning, please remember that we have the airtime program here, whereby you can purchase airtime from your M-Pesa to any line, Safaricom, Airtel, Telcom. Just go to your M-Pesa, Lipa na M-Pesa. The business number of the paybill number is displayed here, 737356. Then the account number is the phone number that you're purchasing airtime for. It can be your own phone number or the phone number of a friend that you're purchasing airtime for. Then after that, now you can enter the amount, you complete the transaction, then you shall be receiving your airtime instantly from our facilities. So thank you so much for accessing that 737356. That is the paybill number. Look at number 3 now. Make G, capital G, the subject of the formula. E plus X equivalent to X plus equivalent to X plus, we have now the square root of G minus 3U divided by Y minus 3XG. So at this point, because I can see some terms which are the same, I'll group in my solution now. I'll begin by grouping terms together, whereby X and X grouped together will cancel, because when we take the first X to the right, it will be subtracted there. So X minus X, that one cancels. So I'm having E equivalent to the square root of G minus 3U out of Y minus 3X capital G. At this point now, allow me to just square both sides. Yeah. Allow me to just square both sides. When I square both sides, now letter E will become squared. Then this side now, I will have the square root sign disappearing. So G minus 3U out of y minus 3xg. At this point again, we can cross multiply such that we don't have this denominator now. So it will be e squared multiplied by y, and again e squared will be multiplied by 3xg. 3xg. So allow me begin with the constant 3, then e squared x g, like that. Yeah, this is equivalent to capital G minus 3 letter u. You see now we have two terms which are containing letter G, so they can be brought to one side. And to do away with a lot of negatives, allow me take them to the right hand side, whereby there is already G at this point. Then I add 3 e squared x g, then negative 3 letter u will be brought to the right, to the left. That way. So this one I'm taking to the left, but the whole of this I'm taking to the right. So I've done that interchange. Now, at that point, allow me now to factor out letter G. So I'm still having my e squared y plus 3 letter u. This is equivalent to letter G. Then we have 1 plus 3 e squared x. Yeah, we have factored out letter G. So at this point now, we can remain with the letter G, but we divide it through by whatever is in brackets now. So that we remain with e squared y plus 3 letter u. This is divided by 1 plus 3 e squared letter x. So that is how you should play along with all the variables involved in the given formula until you get the subject that you intend to get. Remember, our consultation line remains here. Remember to subscribe to this platform. Remember to share our link with all your friends so that they may continue to learn just as you're doing. Number 4 is on binomial expansions. Expand 1 minus a third x to the power of 6 in ascending powers of x up to the 4th term, leaving the coefficients as fractions in their simplest form. Mark this: fractions, simplest form. Though, even without the word simplest form, it is very good for a learner to know that fractions are always supposed to be left in their simplest form. Look at this now. For us to expand, I would advise let learners begin by stating the Pascal's coefficients of the given power. For instance, here we go to power 6. So when you go to the mathematical 4-figure tables, you will find the powers of, the coefficients of power 6 listed clearly from the first coefficient to the 7th coefficient. So in this case, we are interested with only up to the 4th term. Therefore, the first term will have a coefficient of 1. Then we have the second term having a coefficient of 6. The third, a coefficient of 15. And the fourth, a coefficient of 20. Coefficient of 20. So now with this now, we can begin our expansions, whereby in the first case, we will have 1 raised to the total power of 6, then negative a third x raised to power 0. But in the next term now, which is the second term, 1 takes power 5 is negative a third x takes power 1. Here we shall have 1 power 4 and negative a third x ascends to power 2. Then finally, in the fourth term, 1 will be power 3, and negative a third x is going to be also power 3. Now we can do our expansions, whereby 1 times 1 power 6, then multiplied by negative a third x power 0. Remember, everything power 0 is just 1. So we have 1 times 1 times 1, and the first term remains 1. Then in the next case, we'll be having 6 times 5, 1 power 5, which is just 1. So 6 times 1 multiplied by negative a third x multiplied by 1 remains the way it is. So it will be 6 multiplied by negative a third x. So 6 by a third becomes 2. And remember, there is a negative there. X. Then the next term, which is going to begin with a plus, of course, is now 15 multiplied by 4 power, okay, 1 power 4, which is just 1. Then we have a third squared and also x squared. So negative a third squared becomes 1 over 9. Negative a third squared becomes 1 over 9. Now without a negative, then times 15. And this is going to give us 1 and 2 thirds. 1 and 2 thirds, the value of x squared. And finally, we shall have a negative at the fourth term, because this is 20 multiplied by 1 power 3, which is just 1. So 20 times 1 multiplied by negative a third power 3 becomes negative 1 over 27. So negative 1 over 27 multiplied by 20 1 over 27 will be negative 20 over 27. Yeah, negative 20 over 27. But now x is to power 3. We are done. Fractions, simplest form. We cannot simplify further. We cannot introduce decimals, so we are done. Use your expansion in A above to estimate the value of 9 over 10 power 6. 9 over 10 power 6. So ours is now to equate the bases, because the powers are the same. The powers are the same. Now we will say this. Let me simplify it for you. We'll be talking about 1 minus a third x power 6 equals to 9 over 10 power 6. So because the powers are the same, we can now equate bases. So 1 minus a third x equivalent to 9 over 10. Now, we can now group terms here such that 1 over 3x goes to the right, where it will be positive. Then 1 minus 9 over 10 to give us 1 over 10. To give us 1 over 10. So how do we remain with x? By multiplying both sides by 3. So we get 3 over 10. And remember, 3 over 10 is just 0.3. So x equals to 0.3. Now that x is equal to 0.3, we need to apply it in our expansion such that we have 1 minus 2 into 0.3, then plus 1 and 2 thirds into 0.3, this time round squared, minus 20 over 27 with 0.3, this time round power 3. So now whatever we are having here as an expression, we are going to key in to the calculator so that we may get the exact value, not the exact value, but the estimate value of 9 over 10 raised to power 6. So I begin with 1 minus 2 into 0.3. Then I add 4 over 3 into 0.3 squared. Then finally I subtract 20 over 27 into 0.3 power 3. So this is exactly going to be 0.5. Yeah, getting 0.5. It's an estimate value. 0.5. So that is it, 0.5. We got a number 5 here, which is from statistics. Number 5 is from statistics. The heights in centimeters of 7 students were recorded as follows: 143, 139, 145, 154, 159, 147, 156. Find the interquartile rate of the data. Find the interquartile range of the data. So for us to find interquartile range of the data, remember, interquartile range of data is one of the measures of dispersion. And in this particular case, what we should begin with is arranging the data in ascending order. So the least value when it comes to the heights of these particular students, we are beginning with 139. 139. Then after 139, we can talk about 143. 143. Then after 143, 145. Then after 145, we can talk about 147. Then after 147, we can talk about 154. After 154, we can talk about 156. Then we will have the tallest learner, 159. 159. So we have marks of 1, 2, 3, 4, 5, 6, 7 students. Now with these marks, the first thing we are supposed to identify is the median. So the median mark, or the median height, sorry, the median height, that is the height at the center, is going to be 147. When the data has been arranged in ascending order, the value at the middle is called the median, which is otherwise called the Q2. So this is another name of median, Q2. Then after the median has divided data into 2 equal portions, now there is usually median of the lower set of the data. So the median of the lower set of the data is going to be found here, because the lower set of data now is having 139, 143, and 145. So their median is going to be 143. This one now, median of the lower set, we'll call it Q1. Q1, also known as the lower quartile, is the median of the lower set of data. Once you obtain median, the lower set can have its own median. Then the upper set, which is now comprising of 154, 156, and 159, we can also obtain the median there, which will be called Q3. Yeah, so we have the median for the total set of data, median of lower set, which we are calling Q1, or rather lower quartile. Median of the upper set, which we are calling Q3, or rather the upper quartile. Now you're supposed to know that interquartile range is usually the difference between interquartile range is usually given by the difference between Q3 and Q1, just that. So we take 156 and we subtract 143, and we will be having 13. Yeah, I think 13 is our interquartile range. 13, that's the value. So some other times you can be told to find the interquartile range. That will mean interquartile range divided by 2. Yeah, such a thing. Looking at number 6, I can see some trigonometry, can see some surds. Then we are advised to simplify by rationalizing the denominator. by rationalizing the denominator, which means this denominator now will first be expressed as what we call a simple special angle. Look at this. If again I apply the unit circle, then we measure some angles here. In the first complete cycle, I will have an angle of 360. But now you see there is this concept of angles greater than 360, whereby for me to occupy an angle of 420, after 360, I have to overlap, whereby now I'm supposed to add a complete 60 in the first quadrant. So 360 plus an overlap of 60 for me to measure an angle of 420. Therefore, it's good for you to know that the trigonometric ratios of 420 are going to behave as those of 60 in the first quadrant. So the quadrant, again, is very key. So how does 60 behave in the first quadrant? Now we are supposed to express the sign of 60 in what we call a third form. Let me show you how we'll come about that one. We can use an equilateral triangle, whereby in this equilateral triangle, there is a length of 2 units, such that this is 2, and this is 2, which means the angles are 60, 60, 60. But now if we choose to bisect this particular, I will have, instead of 2 units, I'll have 1 and 1. And again, I will have 3, 0 instead of 60 up there. So this has become right angled, and we can also get the opposite length here. What about this height? How do we get it? So let's calculate that height. So using the first triangle or one of the triangles, I need 2 squared minus 1 squared, then I take the square root according to Pythagoras theorem. So 2 squared minus 1 squared, then I take the square root. So I'll be talking of the square root of 3. So this side will be root 3. So if that side is root 3, now we can talk of the sine of 60. Sine 60, which in this case will behave the same as the sine of 420, will be sine of 60, opposite length, root 3, out of hypotenuse, 2. So now we go to the expression there and we rewrite it. We have to rewrite it here. Say the root of that 2 can still be simplified. Remember, in that 2, there is a perfect root of 16. So that 2, let me start by simplifying that 2 equals to 16 by 2. So the root of 16 is known, 4. Then root 2. So instead of that 2, we can have 4 root 2. So we'll be having 4 root 2 divided by 1 minus the root of 3 out of 2. Yeah, the root of 3 over 2. So now with this, we go directly to rationalizing now. Directly to rationalizing the denominator, whereby now to rationalize the denominator, we have to talk about what we call the conjugate. And conjugate of the denominator is 1 plus the root of 3 over 2. Then up there, we also multiplied by the same conjugate. We multiply the numerator, the denominator. Look at it in this way now. When you multiply a third with its conjugate, you usually get a rational number. Therefore, from the denominator, which again looks like what we call a difference of 2 squares. So to factorize this, or to simply expand this, we will need 1 squared plus the root of 3 over 2 also squared. So at the denominator now, we expect 1 minus root 3 over 2 squared becomes 3 out of 4. 3 out of 4 when we square, because root 3 squared is 3 and 2 squared is 4. Then now up there, we can now open brackets whereby we will have 4 the root of 2. That is after multiplying by 1. Then we multiply again 4 the root of 2 by root 3 over 2. And when you'll be multiplying that, you shall discover something, that 4 and 2 will cancel. This 2 down here, now I'm multiplying 4 root 2 multiplied by root 3 over 2. So 2 and 4 will cancel, so that we have 2. Then root 2 and root 3 will become root 6 that way. This is now what we are having. But we can simplify further. So we will have 4 root 2 plus 2 the root of 6 divided by 1 minus 3/4, we get a quarter. So we can multiply now for us to do away with this fraction, which is at the decimal. We can just multiply everything by the reciprocal, so by 4. So a quarter is multiplied by 4 to get 1, and everything on the numerator also by 4. Or in simpler terms, can we have it as 4 the root of 2 plus 2 the root of 6? Then now to divide by a quarter means to multiply by 4. Means to multiply by 4. And because our intention is to rationalize and simplify, actually I will not open the bracket here. Instead, I'll factor whatever is common, which is 2. So you discover that inside the bracket there is a 2, which can be factored. So that will remain with 2 the root of 2 plus the root of 6. And now that we have factored out 2 and we add a 4 outside the bracket, now the 4 which was outside the bracket now becomes 8 because of the 2 that we have factored. So this is now the simplest final answer in that particular case. Yeah, as we continue learning, please remember to subscribe to Shifting Grades. Remember to share for you to invite friends who are in secondary school. Share this with them as we look at number 7 now. Yeah, number 7, a very good question, which is talking about this is on probability, right? Yeah, a bag contains, you have to be very careful here. A bag contains 840 beads, which are white and black in color, in the ratio 5:7, in the ratio of 5:7, respectively. Bag B is another bag now, contains 660 black and white. They are also black and white again. The beads in bag A and B are mixed in bag C. So we have a different bag now. The final fixture contains black and white beads in the ratio 7:8. Find the probability that 2 beads or balls, can say beads, drawn from bag B, one at a time without replacement, are of the same color. They are of the same color. So let's begin by applying some proportions here and ratios, whereby we will say if black and white, okay, white and black in this ratio respectively, 5:7. So we can see the total proportions are 12 because of 5 and 7. So for us to get the number of white in A, we need to talk about 5 out of 12 multiplied by 840. This will give us a certain number. This will give us 350 exactly. Those are the whites in bag A. Then we are also talking about the blacks in bag A. They are going to be 7 over 12 by 840. So we can also get this number, 7 by 840 over 12. I'm getting 490. 490. All right. Now look at this. We are again mixing. All the balls now. We're mixing all the balls such that they have been put together in bag C. So inside bag C, how many balls are we having? 840, which were in A, 660, which were in B. So we are having a total of 840 plus 660. This is 1500 exactly. We have 1500 balls. Now, these 1500 balls are in a given ratio. Such that if we assume that the 660 in bag B, because they are both black and white, they are both black and white, then we can say that we can let inside the bag B now, we can say that in bag C, sorry, out of the 1500, we can say we had a total of, let me check the ones we are beginning with, white. Then in the mentioning here, for us to get the final ratio, we have black and white. And I hope this ratio is also respectively. Therefore, in bag C, in the bag C, black comes first and white later. So black are 490 plus X. When we divide by the white, and you know the whites are initially 350, and 350 are the ones which were in bag A. Then in bag B now, we are having the balance, which is when we take 660 minus the X which are white, we are supposed to get a ratio of 7 over 8. Allow me simplify or explain how I'm coming up with X and 660 minus X. Assuming that in bag B now, the black in B are X, then white in B, they will be 660 minus X. That is what I want you to know now. In bag B, if we assume the black ones are X, then the white are the remainder. They are a total of 660 in bag B. Therefore, the balance is now 660 minus X. Therefore, now we are putting all of them together in bag C, and the ratio becomes 7:8. And this ratio is of black is to white. Therefore, it will be very right to argue that when we take all the blacks in A plus the blacks in B divided by all the whites in A, 350, divided by all the whites in B, 660 minus X, we should get a ratio of 7/8. Yeah, 7/8. So now we can find something. I think 350 plus 660, this is we call it 1010. Yeah, we get 1010. So 490 plus X out of 1010 minus X equals to 7/8. So we can do a cross multiplication whereby 8 goes with 490 and that is 3920 plus 8x equals to 1010 by 7, and that will be 7070 minus 7x. You know, here we can play with what we call a like terms, whereby 7x can come to the left, which will be 15x. This is equivalent to 7070 minus 3920, giving me 3150. So that the value of x now can simplify. When we divide by 15, we'll get 210. So x is the number of blacks in B. So in B, blacks are 210. So that we say, when we take 660 and we subtract now our 210, you get 450. So the whites in B are 450, the blacks are 210. That one required a student who can really think. Yeah, who can really think. Now let's get to the exact question. Remember, we are not through. Find the probability that 2 beads drawn from bag B, one at a time and without replacement, are of the same color. So now allow me now to do what we call a tree diagram using 210 and 450. So from bag B now, we can select either black or white. Selecting a black for the first time will have a probability of 210 over 660. And white will be 450 over 660. Then now we can pick again, whereby we can still pick black or white. Now picking black for the second time, we'll drop from 210 into 209. Let me write it well as a fraction. 209 over, instead of 660, because this is the second picking and there was no replacement, we'll talk of 659. But picking white, when we had picked a black, the whites will not have been affected. So it will still be 450 over 659 that way. In the second branch here, we can still pick white again or black. After picking white again will go down to 449 out of 659. Then picking a black, when we had picked a white, the blacks are not affected. So there will be 210 out of 659 that way. So you can see in my simple tree diagram, I can talk about black, then black, white. Then we can talk of white, black, and white. So what is the question asking? Probability that 2 balls drawn from B, one at a time without replacement, are of the same color. So we need probability blue. They're not blue, but black. Probability black and black, or probability white then white. So here we will talk of 210 over 660 multiplied by 209 out of 659. This one plus the other option, which is a white followed by white. So 450 over 660 multiplied by 449 out of 659. So this is something now which can be computed very quickly. 210 over 660 multiplied by 209 over 659 plus 450 over 660 multiplied by 449 over 659. We are assuming that I have computed everything right. I'll be having the probability as 4099 out of 72, 49. Or simply, this can be given as a percentage of 56.55%, or as a decimal of 0.5655. So probability can either be a decimal, a fraction, or a percentage. All those are options of expressing a probability. At this point now, allow me focus on a different question, which is a number 8. Number 8 is a question on, this is a question on a commercial arithmetic, and we are supposed to be very careful when handling commercial arithmetic, since it is one of the prime topics which frequently will appear in the national exam. Actually, it is rare to encounter Kcse without commercial arithmetic. So let's be very keen in the working out of this question. Levi bought a new motorbike on hire purchase. The cash value of the motorbike was 960,000 Kenya shillings. He paid a deposit of 20,000 Kenya shillings, followed by 24 monthly installments of 5,000 Kenya shillings each. Calculate the monthly rate at which compound interest was charged. There's something you're supposed to know here, that a compound interest, or even interest of any type, can even be simple interest, but it is usually charged on the balance once deposit or down payment has been made. So after making a deposit, what was the balance? The balance was 96,000 Kenya shillings. We subtract a deposit of 20,000 Kenya shillings. So when we subtract 96,000 and 20,000 Kenya shillings, we'll be getting 76,000 Kenya shillings. Now, this is the money which is going to earn interest. This is the money which is going to earn interest. In other words, we will call it our principal. The balance, the initial balance, is called the principal. Now, this principal will earn interest with the time. So we can see the amount which will be paid. Instead of 76,000, Levi is going to pay 5,000 multiplied by 24 months. 24 months. And this is going to be, let me work out that. This is going to be 120,000. 120,000. Now calculate the monthly rate. This one is again very key. It's a very key language. Monthly rate. Monthly rate. So we will be talking again of amount is known, and you know that amount is usually given by principal into 1 plus rate. This is compound interest formula. Rate, which is a percentage raised to n. N is the number of interest periods. So we are talking of amount which is equivalent to 120,000 Kenya shillings, a principal of 76,000, 1 plus rate that we don't know over 100, and this one is raised to 24 months because the rate is needed per month. So we can divide through now. 120,000 over 76,000. This will be 1.579. This is equal to 1 plus rate over 100 raised to 24. Now, to do away with this power, we have to obtain root 24, both sides. So 24 shift power. That is what you'll type in your calculator. 24 shift power of the value there, whereby now after obtaining 24 the root, I'm getting 1.0192. 1.0192. This is equivalent to 1 plus r over 100. Yeah, r plus 100. So at that point now, we can subtract 1 from the other side, remaining with 0.0192. And this is okay. I can even add another digit there. There was a 1 there, yeah, so that we may have an accuracy of 4SF, r over 100. So to remain with r now, we have to multiply by 100. And for this case, we shall have a rate which is 1.921, and this is percent per month. So the rate is per annum. The rate is per annum. That is how we work out such a problem. Okay, we go to number 9 here. Very good question on equations of a circle. Yeah, equation of a circle. Given the equation of a circle, which is 4x squared plus 4y squared minus 8x plus 8y, then we have minus 7 equals to 0. Determine the coordinates of the center of the circle and also the radius of the circle. So the first thing is to group these, to rearrange the equation so that we have the x components and the y components. Then for each component, we complete the square. So we are having 4x squared minus 8x, that is the x component, then plus 4y squared plus 8y. Yeah, then we can take the constant to the right, whereby -7 will get added there. So we can complete square for the x component now, whereby for us to complete square, we have to divide through by the coefficient of x squared, whereby everything here will be divided by 4 throughout. So we will have x squared minus 2x plus y squared plus 8y equals to 7 over 4. And now at this point, we can complete now squares comfortably, whereby x squared minus 2x, this is now the x component, but we have to make it a perfect square. So we have to add a constant here, such that this constant is given by the value of b over 2 squared. So -2 over 2, and we square. It will be -2 over 2, which is -1. But when squared, it still remains 1. Plus y squared plus 8y plus, we also complete the square for this y component. So we take 8 over 2, then we square. 8 over 2 is 4, and squared will give us 16. So this is equals to, we have 7 over 4, and we have to add the two constants here, 1 and 16, that way. 1 and 16. Yeah, so the other thing to do now is to do what? We factorize. We're supposed to factorize both the first perfect square and also the second perfect square of y. So the square which is in terms of x can be factorized, whereby we take the square root of the first part, x, the sign which follows, which is a minus, the square root of the constant, which is 1 squared, plus we factorize the function which has y. The square root of y squared is y. The sign which follows is a plus. The square root of the constant is 4 squared. So now we have factorized both the x and the y components. This is equivalent to, when we take 7 over 4 and we add 1, then we add 16 again, I'll be getting 18 and 3/4. 18 and 3/4. So here we are supposed to get 2 answers. The first answer for A is the coordinates of the center of the circle. The general equation of a circle is usually x minus a squared plus y minus b squared. This is equals to radius squared. With this analysis, we can see now the equation that we are having is already in this general format. So we can say if A and B is the center of the circle, then negative A is equal to -1. Negative A is equal to -1, according to what we have there. So the value of A will be 1. Again, negative B equals to 4, which means the value of B will be -4. Therefore, we can talk about the center of a circle. This is answer of part A. The center will be 1, -4. Then the radius squared equals to 18. The radius squared is now the part here, 18 and 3/4, whereby we can now take R to be, when we obtain square root of this value, the square root of this value, which is going to be 4.33 units. So now we are having the center and we're having the radius for this particular circle. Consultation line remains on board. So remember to use it wisely. Looking at number 10 now. A matrix T, which is equivalent to x minus 7, 1, x minus 4, maps a square of side 2 centimeters onto a quadrilateral whose area is 12. Determine the value of x. Hence, determine the matrix that maps the quadrilateral onto the square. The quadrilateral onto the square. All right. This is a very interesting question, whereby I first want you to know that area of the square, and the square is original object. Area of object is 2 by 2, which is 4. Area of image is given as 12 square centimeters. So with area of image and area of object, we can obtain something called area scale factor. Area scale factor. At this point, we can talk of 12 over 4. This is now 3. So we have area scale factor of 3. Then something else we're supposed to know is that the value of determinant is usually equal to area scale factor. Therefore, the determinant of the responsible matrix in this particular transformation is supposed to give us a value equivalent to the area scale factor. Therefore, we can say that determinant, which is given by product of elements in the leading diagonal minus product of the elements in the other diagonal. So we are talking of x multiplied by x minus 4, then minus 1 multiplied by -7, we should get 3. This is x squared minus 4x. The -1 by -7 now has to change to 7 equals to 3. You see now, we're having a quadratic equation here, which can be solved through several approaches. This is a x squared minus 4x. Then this is plus 4 equivalent to 0. When that is equivalent to 0, allow me say that we can use factorization, whereby we need a product of a by c. So 1 by 4, which is 4, and sum, which is equivalent to b, which is -4. So -2, -2. We have to write x squared minus 2x minus 2x again. Now, instead of -4, we are splitting it to -2, -2, then plus 4. This is equivalent to 0. So from the first two terms, we will remain with x minus 2 in the brackets. Then in the other two, we also remain with x minus 2 in the brackets. So you discover that in the brackets, we have x minus 2, and also outside the brackets, we have x minus 2. This is what we call now a perfect square, equals to 0. Therefore, the value of x equals to, value of x is equivalent to +2. Yeah, a perfect square has only one root. If the value of x equals to 2, we can now find the matrix up there, the specific matrix. So the matrix T equals to 2, -7, 1, and then 2 minus 4, which will become -2. Yeah, 2 minus 4 is -2, that way. So this is now called, the matrix, the specific matrix which mapped the square onto the contralateral. But look at the question that we are having. Hence, determine the matrix that maps the contralateral onto the square. In other words, which matrix will reverse the contralateral back to the square? And that is the inverse of this matrix. In other words, we are told to find the inverse of T. Find the inverse of T. That is a polite language of demanding the inverse of this matrix, because we need the matrix that will reverse the transformation. So let's now find the inverse of T. To find the inverse of T, we need to get the determinant first. So the det of T is going to be 2 by -2, then minus 1 by -7. This is going to be just negative, this is -4, +7. This is 3. Actually, we didn't even have to calculate determinant, because we say determinant is equal to 3. It is supposed to be equivalent to area scale factor, which is already calculated, but we have confirmed that it is 3. Now that it is 3, we have to divide every element by 3. So for us to get the inverse of T, we need to divide by 3 the elements, but there's something we do. In the leading diagonal, if we have 2 here and -2 on the other position, now we change their positions. -2 comes here and 2 goes down there. Then now in the other diagonal, we have to change the sign. We reverse the sign such that -7 becomes 7, and 1, which was positive, now becomes -1. So now this is the matrix. The inverse of T is the matrix which will map back the quadrilateral onto the square. The quadrilateral onto the square. So that is it. We can now look at the solution for number 11. The coordinates of 3 points are A, which is k minus 5, -15. B, we have a 10k. Then C, 6, -k. Find the 2 possible values of k if points A, B, and C are collinear. If the points are collinear. So the first thing we are going to do is to find some 2 vectors out of the provided points here. We can get a vector like AB. Let's find vector AB. You know, we need B minus A. So we need 10k minus A, which is k minus 5 then negative 15. This is going to be 10 minus k, then negative 5. That will be 10 minus negative 5. It becomes positive already. So we talk of 15 minus k. Then here we have k minus negative 15, which will be k plus 15. That way, that is vector AB. What about vector AC? Vector AC. Vector AC will be given by C, which is a 6 negative k, and A, subtract A, which is k minus 5 negative 15. So this is going to be 6 minus k, then minus 5, which will be 6 minus a negative 5. That becomes a positive. So will be 11 minus k. And down here we will have negative k minus a negative 15. So 15 becomes positive, but k remains a negative. So we have we got two vectors from the given points. So what we are supposed to know is that there is a certain constant which multiplies one vector to give us the other. So there is a constant which can be let to be. We can say that the vector is okay, the multiplier, the unknown multiplier is going to be, let's say, even x. So when we get a multiplier x, it can multiply the first vector, 15 minus k, k plus 15, to give us the second one, 11 minus k, 15 minus k, that way. And therefore, we are now supposed to get two equations here. From the x component, we can talk about 15 minus k multiplied by x is supposed to give us 11 minus k. Again, we can say that k plus 15 multiplied by a constant is also supposed to give us 15 minus k. So now this is what we call now two simultaneous equations which are supposed to be solved. So if we are to solve this one simultaneously, we will find ourselves saying this. Allow me use elimination method, whereby I will say this is 15 from the first equation, 15 minus k into the factor x. This is equal to 11 minus k, and the lower one is k minus positive 15 multiplied by the factor x to give us 15 minus k also. Therefore, elimination means we subtract corresponding values. So here we can talk about negative k minus negative k, which is negative k plus k, and k will cancel from this side. So we will now have 11 minus 15, which is a negative 4, right? Then for the components of x, we have to take 15 minus k, then minus k plus 15. What is this going to give us? 15 minus k again, minus 15 minus 15 minus, let me write it well, minus 15. Therefore, we can talk about negative k minus k. which is negative 2k. Then 15 minus 15, that one will cancel. So when we subtract this and this, we will be getting negative 2k. Yeah, negative 2k that way. Negative 2k, the value of x. So we can say that the value of x is equal to negative 4 out of negative 2, the value of k. And the value of x will be equal to, I'm looking for the value of x exactly. The value of x is going to be 2 out of k. The value of x is 2 over k. So with that, because the value of x has been completely expressed, then we can express k also, whereby k, which is the constant, is going to be equal to 2 over x. So the value of k is 2 over x. If the value of k is 2 over x, then we can use equation 1 here to find x. So we'll be having 15 minus, instead of k, 2 over x multiplied by x equals to 11 minus k, and instead of k, 2 over x. Yeah, that way. Therefore, when I open by x here to be 15, x minus 2 equals to 11 minus 2 over x. At this point, we can group terms now and say, we can say now, when we group terms, we can talk about, let me take actually, this one becomes a 13 because it is 11 plus 2. Yeah, that one becomes 13. Then with 13 at that point, we can also bring 2 over x to the right, to the left, that is, whereby it will be 15 x plus 2 over x equals to 13. And this equation can now become quadratic, such that we have 2 values of x. Yeah, that is what I'm seeing. So we can now subtract the 13 here and remain with 0. When we multiply through by x, it will be 15 x squared plus 2 minus 13. This one multiplied by the value of x equals to 0. So now we can solve 15 x squared minus 13x positive 2 equals to 0. So this one now is what will be solved to give us 2 values of x, whereby after getting 2 values of x, now we will be able to replace it up there and also get 2 values of k. So when you substitute each value of x, you'll be getting an independent value of k. You substitute again the value of x, you get the value of k. So that is what you are expected to do. We'll be continuing from there. Subscribe and share.